All right, next video is about rectangles. So a rectangle is a parallelogram, remember? Parallelogram. It's just a special one. And so it has some special properties. First, you need to remember that it has all of the same properties as a normal parallelogram, which you should have memorized. So the properties of a parallelogram: opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Those are the properties of a parallelogram. A rectangle has an additional property, and that is about its diagonals. So just looking at that guy, you can kind of sense that those are congruent. So the additional property of a rectangle is that diagonals are congruent. Now, other things to remember is that a rectangle is a rectangle because it has 4 right angles. So while that's not a property, that's a definition. The properties of a parallelogram, here's our little parallelogram marks, the same. Opposite sides are congruent, and opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. But in the case of a rectangle, that means each piece is congruent. Before we move on, I just want you to kind of take a look at all the things we just made. So see the isosceles triangle right there? And another one. And another one. Okay, and another one. Also see this right triangle right here? And another one. You will be able to use the Pythagorean theorem and trig when it comes to rectangles as well. All right, let's do a couple examples. You may have printed this, otherwise you're going to have to pause and write it down because, that's how it works. So if JKLM is a rectangle, find each missing measure. So let's just go through and do everything that we can think of. Let's start with sides or segment pieces. If LM is 19, the opposite side is 19. JM is 25, so its opposite side is 25. In a parallelogram, diagonals bisect each other. So if this piece is 13, that has to be 13. But since the parallelogram, or it's a rectangle, these two diagonals have to be congruent. So if this one's 26, adding those together, this one is 26. And since diagonals bisect each other, these are each a half of that. So 13 and 13. All right, now let's look at angles. We have a 68-degree angle here. Hopefully you can kind of see these alternate interior angles, that Z right there. So this is 68 degrees. This one right here, you can find because in a rectangle, the angles are 90 degrees. So 90 minus 68 for this one, that would be 30, 22. 22 degrees. And alternate interior, if this is 22, then that is 22. It's a lot, right? All right, let's see what else we need to find out. Well, let's fill in what we have down here and then go from there. KL, we have 25. NL is 13. KM is 26. Angle KLM is 90 because it's a rectangle. LMK is 68. We did that by alternate interior. And LJM, how are you going to figure out that one? What do you think? Well, one thing you could do is you could be like, well, hold on. Isn't this, and there's multiple ways to do that. Isn't this isosceles right there, that triangle? Well, it is because both of these diagonal pieces are congruent. So it's isosceles. So if this is 22 degrees, then this would have to also be 22 degrees because it's isosceles. All right, we can continue to fill in every single angle in here if we want to. I'm going to do that just because it's fun. and you could pause and try to fill them in yourself also. So this would have to be 68 for same reason. This is isosceles, this triangle, or also that these add up to 90. Over here, alternate interior, 22 and 68. And we actually can find this middle angle measurement as well. If I look at that triangle and I do 180 minus 22 minus 22. So this angle in the middle is 136, which means by vertical angles, 136. And then we can use a linear pair, 180 minus 136, to find out this is 44. And there are other ways to do that also. So you can see there's a lot to do. It kind of ties in everything we've done so far all into one problem. So let's look at some that involve algebra. If ABCD is a rectangle, we want to find the measure of angle ABD. ABD, right here. All right. Now this is a problem about angles, so we're going to think about our angle relationships. We have in a rectangle that opposite angles are congruent. Okay. We have that same side angles are, or consecutive angles are supplementary. So we could do that. But right now I'm focused on these two, which are alternate interior angles. Alternate interior angles are congruent, so x plus 18 is equal to 4x minus 15. All right, I'm just going to solve it real quick. You can pause and solve. All right, so x is 11 degrees, or 11, just 11. I know that this angle has to be 90 degrees. So if I can figure out this piece, I can definitely figure out that one. So 11 plus 18 is 29, and 90 minus 29 is 61. So the measure of angle ABD is 61. All right, I know these are kind of long, but I want to make sure you see all the kinds of examples. And it's not even going to be all the kinds. All right, next. It is supposed to tell you this is a rectangle, so I'm just going to tell you that out loud. This is a rectangle. DE is 4x plus 1, so it looks like this is going to be a problem with diagonals. EB is 12x minus 31, and CD, the bottom, is 28. And what we want to find is this piece here. So let's look at what we know first. In a diagonal, or in a parallelogram and a rectangle, diagonals bisect each other, which means cut in half. So these two pieces are congruent. 4x plus 1 equals 12x minus 31. So this will get us x. So let's solve. All right, so x equals 4. Great. Let's substitute that back in before we decide what to do. 4 times 4 is 16, plus 1 is 17. I like to write it over top like this, just so I can focus on that. 12 times 4 is 48, minus 31 is 17. All right, so now I'm just going to kind of talk you through what my brain is thinking. I know that DB has to be congruent to AC. So I'm looking here at this triangle. This is what my brain is thinking. You might go about this differently, and that's totally fine. So 17 plus 17 is 34. So I really have this triangle here. I know this is 28. I know this is 34. And I'm looking for this. I also know that this is a right angle. So can you see what to do? What do you think? All right, I hope you said the Pythagorean theorem. We can find it by doing the Pythagorean theorem. So I'll just call it A that we're looking for. So A squared plus 784 equals whatever 34 squared is. And last step, you take the square root, is about 19. All right. Hopefully you're good with that one. If not, make sure you ask me some questions. And the last rectangle one. Find the measure of angle JHI. All right. So I see these are angle problems. They're both angles. And I also see they're both pointing here. So it's a rectangle. This is 90 degrees. So I'm going to write 3x plus 2 plus 12x minus 17 equals 90. And solve. So x equals 7. All right, but what we want is this angle, which we know is the same, this angle, as this angle, because they are alternate interior. So we're going to substitute so this angle here is 23 degrees. All right, good luck.